this. How do I share the screen? I just go to bukan, ini ada apa? Moderator room. Oh, sekarang saya biar screen yang you punya pen punya apa screen kan? Okay, once my session start, will you actually show my share screen, or do I have to share it myself? Oh, okay. So I go to share screen and all that. Okay, okay. So I will have to open up my PowerPoint already. Okay, okay, okay. Thanks.
Hi, Mr. Tay. Would you like to test your slide? I can stop sharing. You can take over my screen for a while. Then we play back the video.
Chee Soo Teng.
Can you allow me to share my screen? Give me a second.
Okay.
Can you see my screen? Hello?
Yeah, can.
Huh?
Can you see my screen?
Not. Cannot first, Mr. Tay.
Cannot, huh?
Cannot.
Okay, hang on a second. Let me
Sure.
go back to the... So I need to share my screen here. Can you see it now?
Mr. Tay is a blank. Yes, I can see now.
Huh? Is this the screen you're seeing?
Yes, I can see your PowerPoint.
Okay. Then, working?
Yep, working.
Great. Okay. So, what do you want me to do now? Leave it on or go back to your PEM screen?
You can.
I think I just leave it there, isn't it?
You just leave it on your first slide, Mr. Tay. Then.
Yep.
Yep.
I'll leave it like that. Okay.
Great, Mr. Tay. Great.
So let me know when I'm supposed to start. Moderator Akirachi is supposed to come in and introduce me before I start, right?
Yes, that's right.
Okay, I'll wait for him. Meanwhile, can you see me on the screen? Cannot, isn't it?
Cannot. You haven't on your video yet, Mr. Tay.
Okay. So let me on my video. Okay, let's see on the screen.
Yes, Mr. Tay, you with your nice bow tie. Good
Thank
afternoon,
you,
Mr.
thank
Tay.
you, thank you. That's my signature. Okay.
Yeah, yes.
And then I will then go back and put on my screen, right?
Yes.
Can you see it now? Can you see my slide on the screen?
No.
Okay, hang on a second. I'm going to go back and share screen again. What about now?
Yes.
I'll leave it like that, okay?
Okay. Can, Mr. Tay.
Okay.
Mr. Tay, can you please stop sharing the screen because Mr. Chiu later will have his own screen to introduce you. Just stop sharing. Yeah. On top there. Okay, thank you, Mr. Tay. Hmm?
Hey, Hao Giang, how are you? Unmute first.
Hi, Mr. Chee. You may start now. Mr. Chee, take over my screen.
Okay. I can't see your screen. Hao Giang, can you hear me, Hao Giang?
Yeah, I can hear you. Can you see me?
Okay, good. Yeah, I want to wait for the screen to come on there and do the introduction.
Yep.
How many participants do we have?
No idea.
42, okay. I'm taking over the Panasonic screen. Let me see.
Mr. Chee, you can see the share screen at the bottom. It'll be green color. Do you see it when you click?
Share screen, yeah, okay.
Yes, I'll take over from there. Thank you.
Okay. Yeah, but there's nothing on at all. Good afternoon, participants. Can they hear me? Wait a minute. Okay, you all can hear me. I can get started. Can you put me on the green screen?
Mr. Chee, we are seeing your Zoom's screen right now. You haven't opened your PowerPoint yet.
I have no PowerPoint. I'm just a moderator.
Okay.
Why don't we do this? Just a quick introduction. Welcome to all participants. I think they can hear me now, right? I'm just moderating. Why don't you just put the synopsis of Mr. Tay's paper on the screen? Yeah, of course, there's nothing for me to share. Tay, why don't you put the first page of your talk on the screen?
Okay.
Yeah, okay, that's good. Okay. Good afternoon, participants. Sorry about that little mixed up a moment ago. Welcome to the current paper that's going to be titled Modern Built Environment Fire Safety Strategy, presented by Mr. Tay Hao Giang. For those of you who've been following the PAM series of talks on fire safety, Mr. Tay does not need further introduction. However, for those of you who are a little bit unfamiliar with Mr. Tay, I have known Mr. Tay for more than 20 years. We are both past presidents of the Institution of Fire Engineer Malaysia branch. Mr. Tay is currently on the board of directors of the Institution of Fire Engineers, and at the same time is also a trustee of the institution. Mr. Tay has a degree in building from Harriet Ward, followed by a master's degree in fire safety from University of Edinburgh. I'll now pass the floor over to Mr. Tay. Hao Giang, you can get started, Hao Giang.
Thank you, Mr. Chee.
Yeah.
Okay, good afternoon, ladies and gentlemen. Today, I would like to share with you fire safety strategy for modern built environment. Now, if you talk about strategy, we have to actually look back 500 BC to the master of strategists, General Sun Tzu. He actually has developed the art of war, which is very, very famous. And a few of his philosophy is know thyself, know thy enemy, 1,000 battles, 1,000 victories. And today, actually Wall Street, all the financial corporates are now using his strategy in the financial world. So we, I think, can learn, we professionals, I think, can learn a lot from him in terms of how to prevent fires from happening from the onset during the design. Now, if you talk about built environment, fire safety strategy, definitely you want to look at sustainable fire safety engineering because that is the way forward for the future. And in order to be able to design fire safety buildings, I think what we need is actually to understand fire behavior and the danger of smoke. Currently, this particular area, there are a lot of lack of understanding for professionals, including developers and building owners. Now, what are the, in short, what are the dangers of a fire? We look at whenever there's a combustion, you generate heat, and heat actually is detrimental. Not only that, there'll be a lot of smoke particles being generated due to incomplete combustion, depending on what is burning. And then, of course, one of the dangerous byproducts will be toxic fumes that actually kills. There are a lot of synthetic materials being used nowadays. And for example, the needle punch carpet produce hydrogen cyanide gas. You kill, all you need is about 0.0003 parts per million, and you're dead, even before the heat gets to you. Then, of course, fire also produce carbon dioxide and carbon monoxide. And, of course, water vapor. And what is the danger of water vapor? If you have a lot of cables like telecom, tenaga, when they burn, they use PVC cables. It generates hydrochloric acid gas. When it mixes with the water vapor in the air, it becomes corrosive and toxic. And of course, there are a lot of carcinogen byproducts that is being generated out of fire. And hence, a lot of the US and the rest of the world's firefighters slowly contracted cancer years after they retire. And actually, the latest research by UL revealed that whenever they came out of a fire scene, there are what they call jackets, helmets, everywhere is then deposited with toxic smoke particles. When they undress in the what do you call that, in their stations, all these particles are airborne and is being inhaled. So there are a lot of actually risks not only for the occupants but also for the firefighters. Now, in order to actually strategize the fire safety design, I think we have to look at fire safety fundamentals. First of all is that we need to understand the fire safety principle and the fundamental. This is the prerequisite for all designs. And hence, all these should actually be introduced during the preliminary stage of any project. Fire safety design objective, the main objective also should be life safety. If you look at our UVBL, most of the what they call the bylaws are actually life safety priority. Then you also need to understand UVBL 1984 with Amendment 2012 Code of Standards. But then, do you think that full compliance to building regulation and codes and standards really give you a safe building design? It's not necessary so, because there are a lot of studies that has been done over the years, and then we find that at times you need to actually go beyond the regulations and the standards. That is because until you understand the fire risk and the fire hazards within the building that you're going to design, there's no guarantee. I give you a good example. If somebody is designing, let's say, a headquarters for the blind, and you start to put in the visual fire alarm units, as part of the fire reduction alarm system, it doesn't work. Similarly, if the headquarters is for the deaf, imagine if the M&E engineer design bells as warning device, it also does not work. All right. So there are a lot of other what do you call that examples, some of which I'll touch later on. Currently, residential occupancy risk is also outside code and standards and also regulation, unless it's high-rise buildings. And we are still arguing whether to put in smoke detectors, should it be a sprinkler and all that. I'll leave it for other platforms to debate on this. Also, we need to consider modern city-to-city built environment with mixed fire risks. And it has been proven in many cases, fire incident cases around the world, including in Malaysia. All right. So if you look at our current building regulations, also in the rest of the world, actually they are all prescriptive based. Now, prescriptive based codes and standards or regulations are actually good for normal standard buildings. But if the risk goes beyond the parameters that is defined by the prescriptive code, then you need to actually look at performance-based approach. But having said that, even prescriptive design, you still need to look at fit for purpose and performance approach. Because gone are the days whereby you just take a data and then just design according to it and hope for the best. It doesn't happen that way. So deemed to satisfy design actually may not work at times, depending on the type of building. Design concept must be fit for purpose. That means it's not just assuming that it's going to work, all right? Fire hazards and fire risks at the moment not factor in, because if you're given a building, architects, if you're given a building, you just design according to the what they call data given or specified in the regulation, UBBL. I'll give you another example. If you were to design, let's say, egress path, normally you look at floor density and then you look at what is the width of the protected corridor, egress path, including staircase. In my second chapter this afternoon, I will show you that that is not sufficient, okay? Because we never take into consideration of human behavior. There are limitations for high-rise or mega-sized project. We all know that, if you look at compartmentation, it's impossible to design a mega-sized shopping mall or a sports complex, or even for that matter, any transportation hub. Airport terminals, nowadays, if you look at even the rail terminals, they're huge. Firefighter safety not taken into consideration as well. Now, we need to understand that structure stability is very, very important. It's because when everybody is running out during any fire incidents, the firefighter are the one that runs in, and they're going to spend some time in your building fighting the fire as well as search and rescue for occupants that are still trapped inside. This is actually, of course, we talk a lot about fire incidents, but we never imagine how fast that it can actually happen. In America, every Christmas, the fire statistics goes up. It's because every house will have either a natural or a synthetic, what do you call that, Christmas tree. Now, of course, the decoration, the lightings of the Christmas trees is left 24/7. And the wires are so thin that sometimes, due to the short circuiting, it can then result in a fire of this ferocity. Now, you imagine that you and your family is sleeping next door in the bedroom, and this happened in the sitting room. I wanted to watch the clock, all right? And this is a full-scale fire because it achieved a flashover within only seconds, not minutes, not hours. If it happens in a domestic home, nobody will survive. You're looking at about 1 minute, all right? It doesn't take hours. Similarly, if you look at high-rise buildings, it's going to take very much longer for egress. All right, I will not elaborate on that. I will reserve for the paper after this. Now, what actually fascinated me is that we have a lot of fire incidents in the world, and yet it seems that lesson has not been learned. Until you got one major disaster with 72 victims in Grenfell Tower in London, then only everybody wakes up. But even that, the mitigation measures that's going to be introduced by government is still very, very slow. Well, the second phase of the court proceeding is still going on. Now, if you look at Grenfell Tower, what happened is that it's actually external cladding fire. Okay, why it happened is because anything that is fixed to the external of a building normally do not require control under building regulation, even though we did have certain clauses, certain bylaws that says that above 18 meters, you apply class O rating. But I think this is more than class O, all right? There are some interesting facts that comes out of the court case proceeding now. It seems that the manufacturers actually cheated. They tested the materials, it failed, but then they go on still to actually market the product, all right? Imagine 4 or 5 inches of highly combustible polyethylene that's attached for insulation purposes, because in order to achieve green effect, you want to save what they call heating powers during winter. You have to insulate the building. Okay, so externally, if you look at cladding, there's no detection, there's no automatic fire suppression systems, and current building regulation also focus on internal fire protection, never external. Now, rapid vertical propagation of synthetic fire also is aided by wind shear velocity, because when a wind hits a building, it actually has nowhere to go but move upwards. So imagine if you light up a fire with plastic outside the building, the wind will actually help to carry the flame vertically very, very fast. Also, the temperature sustained. If you look at the videos, it's actually around 1,000 degrees. That's equivalent to a test lab temperature when you test fire doors and the drywall partition. All right. So hydrant water pressure flow cannot hit above 10 story. If you look at here, this is the jet, all right? From the fire brigade, it's only up to this level, but yet this is something like 35 floors. So internal firefighting for this particular pre-war building, of course, is again limited. They got single staircase, and also the landing valve is inside the staircase, which posed another problem. The moment the firefighter pull the hose, 2.5-inch hose, from the landing, staircase landing, into the apartment, it actually prevents the fire door from closing, allowing all the smoke from getting into the staircase, and egress is practically impossible. The heat, the smoke, you can't see anything. Even the firefighters find difficulties, all right, going up for the rescue operation. So there are many, many considerations I think we need to start reviewing and start to think. This is actually a photo, and you can see that this is a lift landing door. We are now actually developing a Malaysian standard to test lift landing door, and they all now has to be fire rated, including insulation. The entire compartment was actually burned. You can see that, and this particular Grenfell Tower is actually just renovated, and they even have double glazing window. They spent something like 16 million renovated, but very, very little on fire protection. Very sad. You can see that even the window melted because of the temperature, except metal that is left, the rest of it gone. Now, Interestingly, I think if we could look at the human tenable temperature, then you can see that we can only sustain maximum 180 degrees. And even that, you're going to have a very serious skin burn. Okay? And this is about boiling water temperature. So, but in any fire incidents, minimum temperature achieved would be about 500 degrees C. Range from 500. If you're talking about smoke, is about 250, all the way to about 900. For Grenfell Tower is beyond 1,000. All right. At this particular incident, what I'm talking about is the external cladding incident. Actually happened before, way before Grenfell Tower. The only difference is that nobody gets hurt. There's no casualty rate. That's why insurance takes over, and the rest is just history. It happened in Australia, it happened in China, and it happened so many times in Dubai. All right. Address Tower on the right is actually in Dubai, and this is so famous. This hotel is so famous. It was actually built right across Burj Khalifa, the tallest building in the world. And the fire actually spread externally from second floor all the way to the top. I visited Dubai about 3 years ago, and since then it was restored. But then you can see because of the Gulf wind that is very strong, this Dubai is actually near the seaside. So that's another reason. I think for cities, we have also vortexes. We also have capillary reactions whereby winds passing through two high-rise buildings that is built closely together will have a lot of effect on fire propagation. So a lot of this is actually issues that I think architects will need to take a look seriously, especially for high-rise, prominent high-rise projects. If you look at China, all the high-rise projects in China and Hong Kong, they went through wind tunnel tests. All right. Now we talk about high-rise fire risk. What about low-rise? This is a very interesting case in Boston. It's a student apartment in the university. Actually, it's below 18-meter height. It's nothing to do with the polyethylene insulation material, but it's actually a high-pressure laminate combustible board. Okay, so a fire started actually on the second top floor, second highest top floor, and eventually spread to the top floor. Luckily, because it's I think early of the night, and most of the students are out, hence there's no casualty. Now, the other thing that we have to look at, of course, basing on a lot of experience, past experience, is that we every time think that when the fire alarm goes off, everybody will then walk along to the nearest fire escape corridor, fire escape staircase, and then escape. Never happen nowadays. You know why? For this particular case, and in many other cases, like the underground train in Hong Kong, it's the same. Everybody nowadays with a smartphone will stop and take video and take photograph because they wanted to be the first to actually share on social media. So again, this is going to affect the reset, requires safe egress time. So a lot of things changes because of the habit of the people or the occupants and all that. So it's no more just design deemed to satisfy. Now, with most of the countries now staying at home due to COVID-19, it's even more important that people actually understand the risk of the building they occupy. All right. This is a very bad time because a lot of office buildings, factories, they are not occupied. There are a lot of things happen. Now, for example, rats probably will be moving around freely, and then they'll be start chewing up the cables because there's no food around. So the risk of a fire happening for unoccupied buildings actually went up a lot. That's why a lot of buildings overseas in the US and in London, they all do still carry on periodical inspection to make sure that everything is okay, especially before they reopen for business. fire is ferocious. So it's not only a plastic that burns. Anything that is wood-based also burns. Now, the other area that is of concern, of course, is curtain wall system. At the moment, during the last few years, there are a lot of steel and glass building, high-rise building is coming up. Now, it looks majestic, except that there is actually a gap between the curtain walling and the floor, and this actually acted as an external chimney. Okay, so this is another area that needs to be resolved. Now, does compliance of prescriptive building regulation in design make a building safe? I think you've got to go and think about it, all right? But so far, there are a lot of fire cases that has been investigated, revealed that building regulation only stipulate a minimum fire safety requirement for authority compliance, which may not be sufficient to address life safety issues. You can look at the project you are doing, and then you could think about it, because normally when you design a building, they are all empty. Now, once the building has completed CCC and handed over, once it's occupied, who comes in? The interior decorator, interior designer will come in. But whatever they're going to introduce to furbish up the building is not taken into consideration in terms of fuel load and the risk of a fire happening or the fire risk during the design stage of the project. Okay. A well-designed fire protection alarm system, effective evacuation of a building on fire. I think this one, again, you think about it. You ask yourself, when you hear a fire alarm in any buildings, do you actually evacuate the building immediately? If the answer is no, that actually you're one of the statistics of 85% in the world that does not respond to fire alarm. And how do we actually effectively evacuate a building effectively within our set? Occupants are aware of all fire safety measures introduced in the building. If you look at a lot of the what they call mega size or modern shopping malls, next time you go around, try to look for the Keluar sign, see whether you can find it on. Nowadays, the building is no more rectangular. It comes in all odd shapes. Sometimes there's a curvature. And normally the exit sign is being placed at the point of exit, either into a fire escape staircase or into a protected corridor. So do we need additional signs, or do we need bigger signs actually to direct people to the actual exit point, story exit or whatever? All fire protection systems maintained in full operating conditions, even though we have the fire certificate where the owner are supposed to do that. I think the best answer would be to obtain from the surveyors, the fire auditors, or the fire risk assessors. They will then tell you the full picture of whether buildings are well protected or not. By fire risk assessment and management, are fire risk assessment and management carried out annually to address the change of fire risk? I don't think so. Even though, unless of course, big corporates, they actually do that. People like Twin Tower, they do that. People like KL Tower, KL Communication Tower probably do that. The rest of the high risk of big corporate officers, they do that. But what happened to the other probably 75% of the building, especially hotels and all that? We actually try to outpace each other. All the countries are now competing to actually build higher. Of course, there are a lot of commercial reasons. One, of course, the land cost is very, very high. Secondly, is that whoever build the tallest will then claim that they are the iconic building in the world. Okay, as we are now talking, Saudi Arabia is going to build one tower that is about kilometers up in the air. Fine. Engineering-wise, architectural-wise, definitely is possible to build. But then when in a country with so much land, why do we need to build that high? Question is being asked, and whether at the end of the day, you need to actually introduce a lot of fire safety strategy to make sure that all the occupants are safe during any fire incident. Okay, you just look at this building. This is a True International Finance Center. I was actually taken for a technical tour, and very interestingly, there are a lot of feng shui inside there. You look at the top, actually it's like 4 palms actually on 4 sides. And the owners actually explained that whatever fortune that falls from the sky is going to be catched by this particular building. They have actually refuge floors in Hong Kong now. They have the built refuge floors every 25 floors from the ground level. This is to actually facilitate where occupants during evacuation, when they feel tired, they can actually rest on these particular floors. Not only that, for this particular building, they have water tanks, because that refuge floors also mechanical floors where they have water tanks for sprinkler system. They also design, the consultant also designed such a way that in times of emergency, if floors below firefighting exercise is not effective, they actually release all the waters and flood it downwards. This is Willis Tower in Chicago, 452, 108 story. Let me ask a simple question, irrespective of age. How many of you think you can walk all the way down 108 story during a fire incident? Petronas Twin Towers so far, I know, actually has a very good evacuation program because of the what they call the connecting bridge between the 2 towers. What happens is that if you have a fire here, all these occupants will have to go into a staircase and then go down to the assembling point. As for all the occupants above the fire floor, they will have to come down by staircase, cross over, and they'll be evacuated by high-speed lift. These are all very well planned during the prelim stage, whereby they have sufficient lift, and their lift comes in twin carriage, all right, to be able to cater for the occupants during evacuation. But these are all men. It's not free for all for anybody. They have actually a management team to actually look at crowd control, and they practice with all the occupants. So this is one of the buildings in the world that I think is very, very safe. And they introduced this decades ago, where the whole world is talking about how to use lift for evacuation. As it is now, Singapore, Hong Kong and China is mandatory for high-rise buildings to use lift for evacuation. International Commerce Center, Hong Kong, 484, 118 story. They also have refuge floors, you can see very clearly, all right? They have refuge floors, 1, 2, I think another one here. I was taken also for the technical tour because I was there during, presented a paper during the Fire Asia International Fire Conference. Shanghai World Finance Center, now Shanghai is actually full of, I think the city has the most high-rise buildings in the world. I think by now they should have about what, 20,000 or 30,000 high-rise buildings. Any building that's above 30 meters. This is Jinmao building, beautiful. The hotel is actually, I think, very, very high. And they have actually a bubble lift all the way right through. Now, if you look at this particular design, even though they have what I call sprinkler spray system along the corridors, I don't know whether it's really safe because you are having a very big volume. Of course, as far as smoke control is concerned, this actually serves as a very good smoke reservoir. But then as far as the smoke spreading from floor to floor, you need steel to do a FDS. At 101, 509 meters, it's getting higher in terms of height, not in terms of story. But when they started this project, I did ask my counterparts in Taiwan, why do you build so high a tower when you are subjected to a lot of earthquake tremors? Do you know Taiwan experienced average 2,000 over tremors and earthquakes a year? Some of it, of course, is very, very low. Richter scale 3, you don't even feel it, or they don't even feel it because they get so used to it. But if you look at this particular design, it's actually very, very safe because the top is actually looks like a bucket, okay, sitting on top of each other. And then when it comes down to here, it's actually broadened. The base, entire base is broadened up. So they have double steel structure column that actually ensure that the whole structure is very, very stable. Not only that, instead of using the water tank for transfer of weight during seismic actions, what they do is that they hang a 30 feet diameter steel ball to actually counteract the pendulum motion of the building. It's a fantastic building, and they introduced a lot of fire safety measures, including movable what they call compartment walls that's hidden in the wall, and then it moves out during a fire alarm stage to actually ensure that all the egress routes are protected. This is in Saudi Arabia, again a very high building, 120 story. I do not know whether tourists or people who stay inside there with children, with seniors, with pregnant lady, with disabilities, how are they going to be evacuated through the fire escape staircase? Majestic building. Those of you who watch Mission Impossible, Tom Cruise, you'll notice that it was filmed actually at a very high level. I'm very fortunate to actually be taken for an escorted tour when I deliver my paper at the 9th UAE Fire Safety Conference in Dubai. The queue, I can tell you, is crazy. Probably going to take hours. It's so long, 100 meters long. But then I was escorted right to the lift and taken up to the observation deck. As I say, no comment. When after the conference, one of the guys who bought the condominium up there come and talk to me. Since the day, I now get a bit worried because I just bought a condominium. He said, can you advise how to evacuate during a fire incident? I say, okay, how high is the floor? 88. I say, great. Ask the developer to give you a parachute. How many of you? 4. Ask for 4 parachute or hang gliders. He was laughing. I say, why do you buy so high a unit whereby at times you see nothing? Because most of the time they are covered with clouds. You can't see anything. You can't see the ground level. So at least, you know, the awareness is being created. And I say you need to actually go back to the management and see whether do they have a proper fire evacuation program. It's beautiful, all right? Beautiful. If you're there, you really feel, you know, we are so tiny, so small. That is the 1 kilometer, 1 kilometer building that is going to come up, all right? That consists of shops, offices, residential, hotel. Observation deck is like 610. You look at the observation deck, I hope they actually provide a lot of securements because the wind shear factor at that height is going to be so strong, all right? Hopefully nobody's going to be blown off. Perhaps they're going to enclose it with glass bubble. And they have 7 refuge floors, all right? Now, refuge floors, there is actually an advantage in the sense that you break the, you don't use the staircase in one stack going down all the way. They go alternate, all right? You come down to the refuge floor, you got to cross over to use the other fire escape staircase to go down. That also solves the problem of pressurization of the staircase. Imagine you're going to pressurize a staircase of 1 kilometer long. It's going to be a huge task, and there's going to be a lot of what they call huge costs. So refuge floors actually provide a lot of solutions, which is very, very good. Not happening in Malaysia yet, all right? Perhaps you should start looking at that. Okay, fire safety fundamentals. If you use fire safety engineering design, you got to look at applied fire and smoke behavior. If you see the two diagrams that I showed, the fire is smaller on the diagram below is because of the design of windows. Look at the windows. If you design the two windows can be of equal area, if you put it horizontally, the air during a fire, when it's burning, it needs air, all right? Any combustion needs air. You draw in the fresh air through the window, definitely the glass will break. You draw it in and the hot air will then be allowed to escape on the top. Now, if your window is designed in this way, the inflow and the outflow of the fire will be limited. So then the amount of the heat produced and the fire size will be very much smaller. If you turn the window the other way around and design this way, imagine there'll be a smooth flow of fresh air and then the hot gas going up. And that actually is the difference, even though the compartment size is the same, okay? So there are actually a lot to learn from fire and smoke behavior when you design fire safety design. Human behavior at the moment is never taken into consideration as far as prescriptive code is concerned. Compartmentation, the moment you actually compromise on that, it doesn't give you any safety at all. For example, if you have a 4-hour wall, you open a door, you open the opening to allow traffic flow between the two compartments, you definitely need a fire resistant door set. Okay. You also need to look for fit for purpose fire protection system. It's not just a system. We normally put in a system that actually stipulated by the UBBL prescriptive code, but never look at the eventual output. If you look at the Tianjin Godao explosion and lately in Beirut, you know that sprinkler system is not favorable for certain chemical that is water reactive. If you look at the explosion in Beirut, it's actually very, very scary. It took out probably about 20–30% of the entire city. Okay. Nowadays, you will need fit for purpose design, performance-based approach. This is not performance-based design. I'm talking about performance-based approach. You got to look at the things that you are specifying, whether it fits. You need to perform during a fire, okay? And not only that, you're going to look at whether does it subject to wear and tear? Does it need to be maintained? There are a lot of things to look at before you select the particular system. And how are they tested? Are they tested fully in terms of performance, or are they tested in samples in a laboratory that actually reflected badly in the external cladding system? What about performance-based standards and codes? This afternoon, I'm going to talk about MS1183. This is a performance-based standard. In fact, we already developed in Malaysian standard for portable fire extinguisher is already performance-based for Class A fires. You do not need to stick to 9 kilo. You look at the fire size, you use the index, you multiply, you can then actually select the type of fire size, extinguisher size that you require to protect that compartment. All right. So we are moving away from prescriptive into performance-based design and approach. Evacuation design also need to be relooked at. At the moment, if you ask my opinion, any high-rise building that is not 40 stories and above, you need to rethink. You cannot get everybody out of the building. Okay, I assure you. Then you need to balance security and safety. How many times you see fire doors are being locked with EM locks? Are they tested? Will they release during an emergency? ERP, ERM, ERT will definitely be necessary. But then this part will then have to be actually practiced by the management, not so much by the architect. Then of course, fire and risk assessment and management, I think is imminent. If architect can actually practice this area, then you find that your design will be a lot different. Issue facing construction industry, prescriptive building design with no specific fuel load. Interior designer added sufficient significant fuel loads after building is completed, fire risk changes with time, maintenance of fire protection systems, change occupancy risk, lease office building, change of tenant, change occupancy risk, market fire safety focus on active and not passive fire protection systems. And of course, there are a lot of industrial pressure to actually reduce or meet only the minimum requirement for approval. Beautiful building. I visited an office that is directly opposite this so-called Museum of the Future, and I can tell you it's fascinating looking at the structure under construction. You know that they use aviation technology to make sure that all the metal pieces outside is actually joined and seamlessly. Eventually, you cannot see the joint. But then when they use that kind of alloy materials, how are you going to break through by firefighters for rescue operation? I don't know. It's really beautiful, but this is one of the buildings that is actually so unique, and then you need a very different approach. What about this particular tower in Dubai that is twisted? At the end, north becomes south, south becomes north. Marina Bay Sands in Singapore is performance-based. Do you know that in the foreign area there's no sprinkler system, there's no smoke control system, because sprinkler is only effective up to 17 meters. And the fire is so high, and smoke control also not necessary because they have large smoke reservoirs above. As long as people can escape before that, it's fine. So this building is fascinating, all right? There are a lot of fireworks display using tall buildings. Is it safe? Still being practiced, but apparently not. If you look at this CCTV headquarters in Beijing, there is actually an office block next to it, okay? Consisting of a 6-star hotel. And one New Year Eve, when they are trying to show the firework display, it started a fire, and before the building is even open, it's burned. In Dubai, they built this called frame, all right? This is a monument. You can actually take a lift up, glass floor, you can walk through, and this virtually segregates the old city from the new city. You can see Burj Khalifa behind, right? So again, if you are talking about this particular type of tourist attraction, how to get people down safely. I don't know whether do they have an evacuation program using lift, and whether the lift capacity is sufficient to evacuate everybody, or does everybody got to walk down staircase? Walking down staircase is not so simple as horizontal evacuation speed, perhaps 1.12 meters per second. Going to a staircase, you take only 80% of that. It never happened, okay? My personal experience was in Manchester. One night, I was actually on the 6th floor, and the alarm went off. Now, walking down the fire escape staircase, not everybody, because a lot of people pop the head out of the door. They say, what happened? When I leave my room, I say, fire alarm, let's go. Go down. You know what? They went back. A lot of them went back to the room. They didn't bother. That proved another point that human is irrational. Okay. Now, as I walk down, I find that I went into a traffic jam. It's because the movement in the fire escape staircase is so slow. Until later, I found that right in the front is actually an obese woman on crutch, helped by a hotel assistant, and they're blocking out everybody that is trying to go down the staircase. Okay, so if you just take the data without reviewing it, without comparing it to the actual happening that is happening around the world, you will never know whether the building is designed, is it safe? As I say, humans are irrational, may not respond to fire alarm. 85%, according to international statistics, 85% of the people do not respond to fire alarm. We are again taking an egress speed fixed, I think for don't know how many that case, 1.12 meter per second, what does it mean? I also don't understand. Does it mean that everybody's physical build is the same, 20 years old, and everybody's leg is also the same length because you have to walk at that speed consistently for everyone? Or I think we better start to look at reviewing that particular data and then come up with a range. Now, if you want to do that, then you can look at what's the percentage of different category of each group in building. So this is all performance based. Yeah, more fit for purpose, more realistic, rather than taking one data and say, as long as I design that, looking at travel distance, I'm happy, I'm satisfied that the building is safe. No. I believe professional architects, engineers, and fire engineers will need to be a thinking professional. We are supposed to be solution provider. All right. So we need to actually review because situation change, society change, human behavior change. If you look at the millennials, probably they don't even bother about fire alarm. Yeah, so we cannot assume that everybody listens to a fire alarm, they're going to walk out of the building voluntarily. No, it never happened. A lot of them, they say, I don't see fire, I don't see smoke, nothing happened. Life carries on. And there are so many incidents that happen. In fact, there's an actual case study being carried in Australia, in the modern mega mall, where they simulate a false alarm. They send out school children to actually do a survey with the occupants or the shoppers. And I can tell you, it's amazing. The answer is saying that, you know, they look at around, life is normal. So assuming that the alarm is false alarm. So I think there are things that modern architects and engineers will have to actually review at the way of practice and hopefully pick up more what they call knowledge to go on. Then, of course, we look at age-induced hearing loss. A lot of, if you look at the care homes, occupants are actually 70, 80, 90 years old. Do you think they can hear the fire alarm? And yet we still design the same. Yep. Fire resistant door sets actually is very critical. I will, because of 1 hour, I cannot cover everything, so I will talk about critical areas. Fire resistant door set, the very, very critical areas, because it actually safeguards all compartmentations. It also enables egress, yet stop fire propagation. It also contains fire, enable it to be a product, and also allow more time for evacuation. So if you look at fire resistant door sets, they are all located at egress routes, fire escape staircase, smoke lobbies, and all compartments. So failure of any one of these important elements of construction will spell disaster for any building. All right. And if you look at Malaysia, there's no or little maintenance for fire doors, and most of them are not in working order. To maintain a fire door, fire rating integrity, there's so many items, right? Door lid, door frame, lock sets, latch sets, lever handle, door closer, stainless steel hinges, auto bolt for double lift, door selector, panic exit device, intumescent strips. So many things to look at, and they're just like your tire. You don't use your tire for 20 years. Tires maximum lifespan is 5 years. So are doors. They're only tested for 100,000 cycle in series lab. Can the fire resistant integrity of door be maintained? Of course. It's not, because you're subject to wear and tear. All right. And what is the lifespan of fire resistant door sets? Well, it's tested to 100,000 cycle. It depends then on the cyclic performance of the door per day. One of my MSc degree students during my lecture in UIA, he did his dissertation basing on collection of statistics, actual statistics of doors on the market. And I can tell you one of the busiest doors we measure, I measured together with her in the shopping complex in KL City Center, amounts to 2,600 over openings per day. If you base on the statistics, test statistics of a maximum performance of a fire door is 100,000 cycle in Syrian. Divide by 10 years, assuming the door lifespan is 10 years, is 10,000 times per year. Divide by 365, is the door can only open 27.4 times a day to last for 10 years. Imagine if shopping center, the door opens 2,000 over times a day. It can only last for months, and yet it's still there after 20 years. Okay, this is a penalty device. You need, it's very, very important. It cannot be locked, okay? Because they are supposed to be opened automatically without what they call that, knowing how to operate the lever handle. If you look at this photo again, they are putting fire extinguishers, and they have another door here that is actually opening outwards that can actually impede escape. So all these actually need to be reviewed. And this door should not be here opening outwards. Opening inwards, yes, not outwards. Fire doors are being tested in Syrian. If you look at these doors, quality control is very important. These are doors that is subject to OMS, open market sampling test, after they got the license, and this door failed at 40 over minutes, not even 45 minutes, with a big hole burning through. So be careful when you select doors. It's not just bomba approved. You need to read the test report. You need to actually look at the door that they supply. Is it the door, the same door that is being tested in the lab? Mass evacuation is very, very important because we adopt mass evacuation. You want to look at perhaps that should not be the norm anymore, because for high-rise buildings, definitely you need phase evacuation. For special group, they cannot be following the mass during evacuation because they are going to slow down the entire process. They should be identified, isolated, and then evacuate using lift, firefighters lift. All right. So there are a lot of things that we need to relook and not just hope for the best. How to get our building during a fire incident? Of course, you look at compartmentation, maximum travel distance, and what do you mean by maximum travel distance? Relevant to who? It's not only relevant to architect in design. You got to look at seriously nowadays how fast or how far can the people travel under the influence of smoke, possibility of smoke. All right. And what about alternate and protective routes? Are there any alternate? The end limits, fire smoke doors. We haven't even looked at smoke doors. All our smoke lobby at the moment is only fire doors. In fact, we'll be looking at smoke, fire, and smoke doors in future. That means once you put in a door, there's no possibility where smoke can actually coming through the door gaps. Okay. Then pressurization is very important. Smoke control is even more critical for mega-size project. And I think for high-rise buildings, super high-rise structures, mega-size, you need assisted and organized egress. It's no more, free for all. All right. We have a lot of signage. If you look at the signage, I think there's too much information and then it doesn't tell you exactly where to go. I think that should also be relooked at. This is the latest format, and you can see that it's very simple because this is not for firefighters. This is for actually occupants or for any shoppers, whatever. You wanted to know where you are and where to go, not where all the fire protection system is and all that, because you're not going to use them. All right. The building management, what I call firefighting team is going to use those. So it's not so much for ordinary people. So less is more, actually, if you look at signage. Okay, about that, why do we still put chloride and emissions lighting on the ceiling? Because that is where the smoke is going to flow and that obscure everything. You see nothing. In China, they put it on the floor. In a lot of the international airports, they also put it on the floor because that is, we are asked to actually crawl when there's smoke present. That's where you can then see, and all these are illuminated, okay? So you can easily find a way out. But make sure you don't go and follow the, what they call Levi's special discount signage. You'll end up in their shop. You see now the modern signage is very, very clear. Tell you where to go. See or not? Very clear cut. There's no, a lot of the mumbo jumbo that is stated there to confuse you. You look at that, where are the fire escape staircase, where are the protected corridor or clearing mark. This is a case whereby It's actually in the lab. They have actually color sign here. I don't think I can see. We are there looking at the what. So I was wondering, why do we keep insisting we put the color sign on top of the door? Because that's where the smoke particle is going to be. If you go to Japan and Korea, they still put it there for floors that is not on fire, but they also put additional what they call arrow signs and exit signs on the skirting level. In Scandinavian countries, they even put it on the carpet, illuminated. So there's no more signage on top of the door. This is a refuge floor. You can see that in Hong Kong, they actually practice a lot of signage, and these floors are actually clear with nothing combustible. Okay, natural venting because they're further, they're quite high up, so there's airflow through the place. You do not need ventilation. Of course, I asked my friend in Hong Kong a critical question that if there's a floor on fire below, the smoke is going to flow up, and then what is going to happen to the people in this particular area? Now, he said, no problem. We have a water curtain, we have a sprinkler, spray and all that. But to me, I think this will have to be tested in the wind tunnel. Okay, of course, they have a steel structure protection and all that. Just now I'll show you MS 183 fire safety code video that we did together with them. Fire safety for occupied buildings. Just now we're talking about new buildings. Additional fire risk added. Renovation expansion may not be covered by original fire protection design. Occupants might not be aware of all the fire safety measures introduced in the building. And as I say, a lot of times, if you look at the existing buildings, maintenance are not there. So forward looking, we need to look at review of building regulations, codes and standards, and application-based testing. Beam fire dynamic combined with egress simulation to aid fire safety design. Intelligence fire detection system linked to mobile app. Why do we need the fire alarm when now we all got smartphone? Actually, they can then send a message straight away, including given direction of where are they supposed to do, all the occupants. 5G that's coming with AI for accurate sharing of fire size, materials science data. And I believe in the next 5 years or 5-10 years, I think there'll be a lot of changes in the fire protection industry. And we can then use all these new technologies, IT, ICTs to help fire safety. China now is already using face detection for head count, occupancy localization. In fact, all these, including thermal imaging and all that, I believe this would be the way forward. There are a lot of wireless plug-and-play detectors, MCP, audio-visual signs. These will then remove further risk of tons and tons of PVC cables running in and across the building. My slide stops to move. Mr. Chee.
Okay, thank you, Mr. Tay. Mr. Tay, thank you for a very interesting talk on what you call looking at fire beyond the confines of uniform building bylaw. I'm sure the architects who are here today will now, hopefully, if this is the first time you listen to Mr. Tay, begin to appreciate the complexities involved in what you call looking at issues beyond the minimum requirements under the uniform building bylaw. Mr. Tay, can you put your slide back on to page to slide number 24, please? While I let the participants know, we will be discussing. There was one question put up during the session done by Mr. Tay. We'll be looking at that in a moment, but just a little quick recap of what Mr. Tay has said for the participants here. Slide number 24, the one that shows the different window opening sizes.
Oh, okay. Wait, hang on a second.
Okay, while Mr. Tay is looking for the slide, participants, Mr. Tay touched on the need to understand the science of fire and the interaction of the chemistry of fire with respect to the way fire interacts with different materials, with different what you call outcomes and chemical reaction, and the effect on life safety as a result. He touched on how the UBBL being prescriptive is based on the minimum generic requirement, and there's a need for designers to analyze whether that minimum criteria is appropriate when you look at designs. I mean, if you remember, rather for those of you who are not young enough, I'll remind you, the uniform building bylaws were basically formulated from the late 60s and early 70s, when anything beyond about 10, 12 story in KL was considered high-rise. Now most of you end up designing condos in the range of the 20 to 40 story range. So what you're looking at in the context of the drafting the UBBL in the 70s is something way beyond what they anticipated or what they were thinking of when they were doing that. Mr. Tay also touched on looking beyond what is UBBL requirement from within for firefighting and protection within the building. We talked about fire spread outside the building, which is something that has been highlighted due to the press in terms of fires, Grenfell Tower, the address in Dubai, and another one in Melbourne. You know, all these fires, and then Kazakhstan, all these fires where external fire spread is no longer suspected but known to be uncontrollable once it's set light. You know, so the science behind was also discussed, and Mr. Tay also touched on the provision of refuge floors in super high-rise buildings, where, like I said, you know, the high-rises that you have now no longer what was anticipated in the early days during the design of medium-rise buildings. And now, for those of you doing super high-rise, you have to not go for looking at UBBL as a minimum requirement. You have to look at it as a base to start from, because that's what it is. Because a lot of the time, I know that there are a lot of architects who consulted me where the clients want to meet with what's the minimum requirement. Minimum requirement based on what? Like Mr. Tay says, based on what? You know, if you imagine a high-rise tower that's 500 meters high, the actual walking distance on the incline downwards is double that height. So if you're talking about 500 meters, by the time you walk from the top floor to the lowest floor of the final exit, you're looking at maybe walking 1 kilometer on the staircase, with the occasional U-turn, you know, to go down another flight. So it's no longer, and if you look at our escape design, we're looking at the floor-to-floor loading on the staircase and the constant discharge. But when you have a super high rise and someone gets stuck on the 20th floor or people on the 60th floor trying to get out, you're going to cause a backlog at the staircase. The staircase is based on a constant motion situation where people are discharging at a constant rate at the bottom. So you can begin to anticipate what the issues are. You know? September 11 in New York at the World Trade Center highlighted the problem that because people are still going down the staircase while the firefighters are going up using the same firefighting staircase, there is an issue of congestion and who has a priority. So those are the issues you have to look at when you're looking at building design. And of course, there's also the effect, what you call the different sizes. Mr. Tay just now showed a slide when he was, I think, about slide 24, talking about how the size of window, whether it's a long vertical strip versus a long horizontal strip, affects the behavior of the fire and what the effect is. And that is precisely the point that was brought up that I would like to remind you. If you look at your 6th schedule, under the limits of unprotected opening, there is a reference to different columns of window height, you know. That is a direct relation to you now. I'm telling you how the fire size is related to the spread of fire from one building to another in proximity. By the same token, a lot of the people now are designing buildings and there's a requirement by local authority and universal access. Now, universal access does not just mean for the ambulance disabled. You now have certain buildings where you have to accommodate users who are physically impaired, maybe poor of hearing, maybe who are sight challenged, and of course, definitely mobility challenged. Therefore, when you design a staircase for the able body to walk down at a constant discharge rate of 45 persons per minute, you know, are you including him as well? If you don't include him, are you going to put him on a refuge floor while the able bodied are walking down the stairs, or are you going to allow him to walk down the staircase, designed to a width of 1.4 meters, for example, and then while someone is carrying or helping him walk down, you now have only half the capacity or to discharge down the particular staircase. These are issues that designers have to think about quite carefully, and not what you call design the blind, and then you know, it disappoints me when the same designers then go to Bombard to argue about this being a minimum requirement and not wanting to comply with anything more. I'm aware, for example, that there's a building in KL now that's having issue with CCC because the designer designed people coming down from a 20-30-story tower bypasses the ground floor because the ground floor is commercial or the lower podium is commercial. The occupants are taken down from the top of a building, 30-story, go down 3 levels into the basement, pass across the basement, go up another 3 floors to discharge. The bylaw doesn't say you can't do that, but common logic dictates that you are supposed to get the people out of the building as quickly as possible. So are you being cynical when you design, looking at those parameters and saying you haven't broken any rule in particular? Can you imagine if you were a pregnant lady, 8 months pregnant, you're going to walk down 20 floors, go down 3 floors in the basement, walk 70, 80 meters across the basement, then go up another discharge 3 floors before you can go out into the open. So these are where some issues that designers will have to conscientiously and ethically balance the requirement of what you call of your commercial requirements versus the life safety requirements. We had a question just now posted by Adeline Chan during the talk, where she was talking about the refuge floor, whether it's provided for in the UBBL, and she was asking about our comments on the issue of unoccupied floors such as mechanical car parks in buildings. Hao Giang, perhaps you want to start on that first before I put in my 2 bits worth.
Okay. Actually, refuge floor is a very new concept. If you look at it, it doesn't come into play until about, I believe, 10 years ago. And of course, to tell the developer to include all these refuge floors, unless it's from the authority, no developers would like to sacrifice lettable floor space because they're so expensive. So, but then if you look at critically, as I pointed out before, I think even for youngsters with good physical condition, you are going to struggle walking down 40-story staircase. Especially, it's not a smooth flow. Everybody is thinking that you walk the whole staircase is yours. No, you're going to be, accompanied by so many occupants, and the speed of everybody traveling is actually different. So sometimes the risk we are looking at is stampede. People get impatient, they'll start pushing. and then you got a lot of people going to get stuck in the staircase, somebody falling down, broke the legs or things like that. And eventually nobody escapes. So we are actually trying to foresee what is actually going to happen inside a high-rise building. That's why when I visited Hong Kong, I think it's a great idea. But again, I asked my good friend who designed the building in Hong Kong that, okay, great. I say, Yang, you introduce the solution, but can I ask you a simple question? Human being is such that when you feel tired, you sit down. You think anybody's going to get up and start walking again? No, no chance. So I say you're going to have a problem of so many people trapped in all these refuge floors. Who are going to manage them? That means that you need something else. You need another program that these people need to be managed. Otherwise, they get stuck there. Firefighters cannot look after them because their job is to fight a fire and then search and look for other occupants that is being trapped inside the building. So there is no provision at the moment in our UBBL that you need to provide a refuge floor. But in China, I was given to understand in Hong Kong it's mandatory now, even in Singapore. So even if you look at our latest 118, there's no refuge floor. Well, hopefully, whoever that is designing will then be able to introduce this to your clients, and we will still make our effort to actually talk to the authority that this is actually necessary. It's a necessity. Okay. Does that answer your question, Adeline?
Please
yeah. I just realized that, sorry. The second part of the question was pertaining to our comments on unoccupied mechanical floors, for example, mechanical car parks.
Mechanical car park at the moment is protected with the sprinkler system. Yet, if you look at some of these mechanical car park, they are actually double stacking the cars. In fact, British research establishment in UK already do a full-scale test. And they find that if you double stack the car and if there is a car fire, the sprinkler system cannot cope, definitely cannot cope. So it's better not to have the double stack car park system. What we do is that we actually, because of my involvement in the Institute of Fire Engineers, we actually got a lot of information coming back from international. Some of these research projects is very, very interesting. And it actually helps us to understand, because it's no more a personal opinion or a thought, personal thought. You need to base, if you want to do anything or introduce any fire safety strategy, we need solid database. That means you get to look at something that has been carried out in research, in a laboratory or full scale. Now, in a car park, let me tell you, the risk is actually very, very high because there's really 2 full-scale fire investigation carried out. One in Belgium and the other one, I think, is in UK. 30 cars, they started 1 car fire and it spread to 30 cars. Because basement is actually fully sealed, there's no way the smoke or the heat can be dissipated. Plus the fact that car fire nowadays, when we park the car, the windows all wind up, we lock the car. So the car fire normally started internally. It built to a full-scale fire. By the time the window is shuttered, the car is burning ferociously. It can go up to about 4 megawatt with sprinkler operating. Without sprinkler, it's 8 megawatt. Okay? So the car fire, before the sprinkler operates properly, you have already spread to the next car. What has been tested is that they purposely leave a space, a car park space empty and park the car on the 3rd car park space, yet the fire still spread. For the double deck mechanical system is gone without conclusion, that the fire spreads upwards so fast. And you don't forget, our car nowadays is hydrocarbon based. Plastic, you look at everything inside the car is easily highly combustible. You got full tank load because Asians always pump full tank, especially now the petrol is going up. You look at Thursday night, everybody go and pump full tank. Then the tires, the engine, there are a lot of cables in the car. Everything is combustible, and oil fire is the most difficult to put out. They are not organic fire. These are oil-based, petroleum-based plastics.
Yeah, Hao Giang, I take that. And another issue I want to add to your answer to that particular question, Adelaine, is the fact that a lot of you are designing multi-story podiums on which the tower blocks sit. And I'm aware that some people have managed to get waiver for sprinkler for a tower block on top because it's residential. But it is therefore essential that you now remember the fact that people who are escaping from fire going to run down from the high rise through this unoccupied so-called mechanical floor container car park before you go out. And as Mr. Tay has mentioned, car fires are no longer what people used to imagine, that the spread won't go beyond the third or fourth car. The fact is that the tests have shown that the Liverpool fire last year has shown that the whole 3-4 story multi-story car park can be totally wiped out with the loss of 200 over cars overnight. Because the spread of fire now, like Mr. Tay mentioned, cars are no longer made of metal. There's a lot of hydrocarbon plastics, flammable materials where, to be honest, beyond about 1,200 degrees, everything will burn. So bear that in mind. We're going to move on. There's another question from an anonymous attendee asking us how to tackle M&E openings through fire sealing in a complex building. That is a very basic question, but I'll let Mr. Tay give the answer first.
Okay. How to tackle M&E opening through fire sealing in the complex building? Now, what you need is actually a fire stopping system.
Yes.
Okay, it's a very simple question. That one is passive fire protection, which is under the architect. So you need to actually patch out all the openings with proper tested fire stopping systems. Okay.
Yeah, those of you who don't know how to design that, you can go and talk to a couple of the commercial, what you call manufacturers of fire boards or fire stopping material, which is, I don't know, those people have heard of what they call intumescent fire collars. Those things will, when triggered by fire, will expand and seal the opening. There are also different types of opening. If it's an aircon opening, for example, the duct itself by right, if it carries through a compartment wall, should be fire rated, and then there should be dampers and fire stops inside the ducting itself. That's another question. Hao Giang, open structure requirement UBBL for multi-story car park, which actually encourage big opening, 40% service opening, will be contradictory to the 6th schedule calculation. I think, Hao Giang, there's a question more for me.
Okay, you can answer that.
Basically, talking about open-sided structure requirements in multi-story car park will actually contradict the requirement of the 6th schedule calculation, where actually less opening is preferable and reduce the setback. I think anonymous attendee, I think you're confusing the reason why people are encouraging big opening in car parks. When you big opening in car parks is to reduce the smoke control requirement. It's not to worry about whether you spread fire or not, because a lot of you, when you design multi-story car park, you don't want to put in, a lot of you try to do isolated car park and a big opening so they don't have to sprinkler, don't have to put in smoke control. But if you're in a podium in below a high-rise building, normally you want the maximum ventilation around the site to avoid the need to put in a smoke control system in addition to your sprinkler. Your sprinkler has nothing to do with the amount of opening that you have. One is for fire suppression, the other for smoke control, because if you have sufficient perimeter opening, you do not require to put in a smoke control system. All right, if you have insufficient opening, you need to put in a smoke management system so that the people can have enough time to get to the fire escape. Okay, now the 6th schedule is talking about how much opening you need to have if you are going to what you call place one building very close to another. The 6th schedule table calculations will let you decide whether the distance you left between you and the opposing building, talking about relevant boundary, is sufficient or not. All right, I suggest you look at the lecture I did. I think you can find it in PAM on the reason why the 6th schedule was in place. By the way, the 6th schedule keeps talking about limited unprotected opening, but the intention is basically to determine the proximity between buildings, so they don't end up with fire spreading one against the other. If you are doing a complex of several buildings, well, you have to balance one against the other. Sometimes you don't have the luxury of what you call having a lot of space between buildings. But having said that, 6th schedule is a good guide to start from. And after that, you then decide on your opening requirements. There's another question coming in from another anonymous attendee. Why are you anonymous? Don't be shy. Don't be shy. Does the fire escape staircase enclosed in protected shaft need to be fire rated? A protected shaft is already fire rated. This question is an oxymoron. There's no answer to it. A fire escape staircase enclosed in a protected shaft, does it need to be fire rated? Are you talking about the physical design of the staircase itself or what? If it is, you're talking about the fire staircase itself, there are two schools of thought. There's some schools of thought that believe that even the staircase design itself has to be fire rated, meaning the actual construction of the staircase itself. You cannot use steel staircase, although the school of thought is that if you're already inside a protected shaft with no likelihood of fire going in, why do you want to worry about, say, making a steel staircase? So I hope that because I don't know exactly what direction you're heading when you ask whether a fire escape staircase enclosed in a protected shaft need to be fire rated. I hope you're meaning the second part, meaning the construction of the actual staircase itself in a protected shaft. Does it need to be fire rated? Basically, the requirement is that it's non-combustible, not whether it's fire rated. Tay?
Yep.
Let me check whether there's another question coming or not. I think those are the only two that we have.
Yep.
If there's no more questions, it's 3:30. Mr. Tay, thank you very much for a very enlightening and illuminating talk. I hope the participants have learned today that there's more to the UBBL than just minimum requirements. I've always emphasized the minimum requirement. That's why it upsets me when Bomba comes to me for reference occasionally due to architects insisting that they only provide the minimum requirement, even though the building is way beyond what the UBBL anticipated. Okay, Adeline mentioned something, thank you, because it's becoming a trend in Penang. It is becoming more common and they are designing in a way to locate beside the residential block. And listening to your lecture just now saying sprinkler system is effective, it's up to 70 meters. Hence, it sparked my curiosity in mechanical car park, modern built environment. Will there be an in-depth lecture on super high-rise and modern building? How many of us get a chance to design super high-rise? We try to cater to the masters. But if you want super high-rise consultation, I'm sure Mr. Tay and I will be happy to talk to you about it. Because it's beyond the UBPL. This is where Mr. Tay talked about whether what you design is fit for his purpose or not. What I designed for a 20-story apartment block may not be fit for a 40-story or 60-story apartment block. The risks are very different. And another issue that a lot of you are unaware of is a lot of you are designing service apartment, hoping to claim that it's purely for residential use and therefore you avoid putting in sprinklers, when in actual fact, the developer is preparing a brochure that says Airbnb investment, which is basically saying it's basically a hotel, with someone changing every other night. Mr. Tay talked about understanding your occupants. If your occupants are living there, they know where the staircases are. If someone who flew in from Thailand, the night before and leaving the night after, they're not going to be interested in where the staircase is. So the time it takes for him to recognize the fire alarm and then finding to reach the staircase is going to be a lot longer compared to a resident occupant who lives there and knows where the staircase is. Okay, I think that's all the time we have. Thank you, Mr. Tay, for your talk again, and thank you to participants for hanging on. I'm happy to hear that, to see that 47 out of 52 participants are still online. So it's a very good sign. Thank you very much, and have a good day and enjoy the rest of your afternoon. Thank you.
Mr. Chee, Mr. Tay, would you please hold on? We're going to do a group photo.
Group photo, okay. Better put Mr. Tay's slide on.
1, 2.
Which slide you want?
1, 2, 3. 1, 2, 3. Freestyle. Okay. Thank you. Thank you.
Thanks, girls. Okay. Bye-bye. Hey, thanks again. I talk to you another time.
Thank you.
Take care. Okay, bye.